Hello everyone. In this video, we're going to take a look at sqlc, sqlc, or sqlc, whatever floats your boat, however you want to pronounce it. We're going to take a look at why you might want to use it, how you can integrate into one of your projects. We'll take a look at how I'm using it in one of my side projects, and what advantages it offers over other ways to interact with a database. So some of you are probably wondering, what is sqlc? sqlc is essentially a tool that we can use to generate type-safe code from SQL. So we could have like this queries file, and from that file, we can generate some Go code and run queries against our database. So what are some features of sqlc? Why might we want to use it? For one, we could potentially have fewer dependencies. For example, we just need to handcraft some SQL queries. Then we can use a driver, say PGX, and that is how we interact with our database. We don't need to do anything fancy. Two, it generates type-safe Go code from our SQL queries. No need to handcraft this code ourselves. It automatically generates them from our SQL queries, which again, we'll take a look at. Schema synchronization. And by this, what we mean is you can pass it a folder of your database migrations, and it will be able to work out what types and what fields it expects to see in certain tables. So if you're trying to insert some data and the table doesn't have that field, sqlc will throw an error, and you can catch those earlier, reducing the feedback loop and improving your developer experience, hopefully. So how do we get started? Well, we write some SQL queries. We use the sqlc CLI tool. Then we can write our application code as normal. If you're used to the 3 layers, you've got your controllers, your service, and your store, or your database layer, or your data layer, whatever you may call that bottom third layer. Well, we don't really have to write that bottom layer now. sqlc will automatically generate that. We are writing it in the sense that we're writing those SQL queries. So, how can we install sqlc? Well, we can do go install like we would other tools, such as golang clint, and this will add it to our bin folder in our Go path. Or, since this is one of my videos, I'm of course going to mention Nix. So we can do Nix shell. You can add it to a Nix flake, which is what I've done with my own personal projects, and I'll show you that later in the demo. Then we want to go and create or edit a sqlc.yaml file at the root of our directory, where our Git folder is typically. We want to create a file that looks something like this. Let's break it down. The first section, we're going to specify the engine, i.e. the database we're connecting to. In this case, Postgres. We're going to tell it where our queries file is. So I've got it in internal store db sqlc query.sql. You can put it wherever you want. Again, where is our schema, our database schema? In this case, I am using migrations, like database migrations. And so I have it in a folder called migrations, and we'll take a look at what that looks like a little bit later. But I'm basically saying, hey, this is changing as I'm developing. It's not this static file. I'm adding stuff. sqlc is clever enough to work it out. And in the documentation, they have a bunch of tools that it supports for running migrations. Next, we're going to tell it where to output the generated code. In this case, we want it with a package of db, and we want it in our internal store db folder, and we want it to use the pgx v5 driver, and we also want it to emit the interface. So it creates a nice little interface called query, which we can then use for unit testing and mocking and other parts of our code. To improve our developer experience a little bit, maybe you might want to look at adding a docker-compose file with Postgres, so we can run Postgres in a Docker container. Then we have an instance of Postgres we can easily test against, and is a bit ephemeral, and we can throw it away when we don't need it, delete the data, etc., etc. And it might look something like this. At some point in the future, I will do a more detailed video about Docker and how I used Docker containers for my own testing and running my own applications locally. But for now, this is a basic setup. Let's get started with some sqlc. Let's create a query.sql file. Here we'll create a comment. We'll call it name. Then we'll call it add user. This will be the name of the generated function. Then we'll add a :1. So we're expecting to return 1 record from the database, not multiple. As you can see, this is a really simple insert query. So we're going to insert into the users table an email of value $1. $1 is going to be some input that the user provides, i.e. we will pass into this function when we call it. and we're returning star, so we're going to return all the fields, columns in the table. So might have a UUID, might have a created at, might have an updated at. We'll also have the email that we've just added in. Next, we'll run sqlc generate, which will then generate our code for us. So we will have a query.sql.go file like this, where we can see we've got the query as a constant variable there. Then we've got this auto-generate function in the sense that sqlc has generated this called add user, which matches the name and the comment. It takes in a context, takes in an email, returns a user, then an error. Then it has a bunch of, if there's an error, of course, then it has a bunch of other code to go query the database and insert and do whatever it needs to do. We'll also create this models.go file, which we'll use to model tables in the form of structs, so we can interact with them in our Go code. So in this case, because we did that returning star in our SQL query, we can see the type user struct, which is basically modeling our user table, has the ID, has the created at, has the updated at, and has an email. We'll take a look at how this schema is defined in just a second when we hit that migrations folder I was talking about earlier. Finally, it generates this other file, which is where we were talking about having an interface. It doesn't need to do this, but we have this query interface, which we can then use to generate mocks with and do other stuff. And you can kind of see it says code generated by sqlc, leaves these comments and the version, so we know not to manually edit it. Going back to our query.sql file, sometimes sqlc isn't smart enough to figure out the name of the field should be, so what it's going to call it in the struct that it generates, so we can use sqlc.arg to force it to use a name if we want to. We will touch on more advanced use cases in a future video, cases and dynamic queries, which are not always the most elegant in sqlc, but something to keep in mind that you can actually do. But yes, if you want to force it to use a certain name, you can do sqlc.arg function, and sqlc will use fields as the name of that field in the struct. So one way we could use sqlc is with static schemas, just provided the schema of our database. I have use Goose, which is a tool we can use to manage our database migrations, similar to something like Alembic, which I've used for my Python web services. We can install Goose like so, and then we can run it like so, goose create, add underscore users of type SQL. We want it to be a SQL file. And this will create new migrations. So it might generate a migration like this. In our migrations folder, it's got that timestamp, then it's got add users.sql. So in this case, if we run the migration, it's going to create a new table called users, pretty standard, nothing fancy there. And then if we want to do the reverse or undo our migration, we've got this down part, which will drop the table if it exists. So of course, during our normal development, we will probably create multiple migrations, add new tables, add new columns, etc., etc. As part of that, sqlc will parse these files and work out what the final state the schema should be. So if we try and add a field, let's say name to users in our insert query, it will fail saying there is no name field. But if we added a migration to alter this table, add a name field, then we could absolutely. And obviously, as you can see, because of the timestamp, they will be ordered correctly. So sqlc has no problem working out what the latest migration is. With some tooling, can cause problems, but that is in the sqlc documentation. So I suggest going and having a read and seeing what tools it supports. So let's take a look at the demo. So this is one of my personal projects I'm working on. It's not Banterbus, but actually, to be fair, I did use sqlc with Banterbus as well. So I've got my sqlc file. Looks really similar to what I showed you. A few changes here. A few changes in terms of like, I'm using a Google UUID. So when it generates the UUID type, I'm telling it to use the Google one. But apparently this is not maintained, so you might want to look at another one rather than doing this one. But I might do that another stage. I'm not sure if this TS vector is actually working. I need to double check that. But this was mostly around the being able to search using free text, essentially. Search for feedbacks, the description. So this is a feedback collection app, my app called Voxical. And so you can go and search, full text search and stuff like that, to see, if there's a word in the description that matches. And so we have this TS vector, which allows, it's a TS vector type. But I'm not sure if this is doing anything, but that's neither here nor there. That's something I can test. Then if we go to query.sql, which will be similar to what I've showed you before, you can see some of these more dynamic queries I was talking about. They're not necessarily very nice, and maybe I should handwrite them, but we'll see. So you can see how I'm using that search vector to search if the user enters in some random words or words into the text box. Then we're basically saying, if we've received statuses, then we expect it to be, when we're fetching feedbacks, we want it to be one of the statuses. So a status, it can be something like in review, in progress, completed, that sort of stuff. Like, what has happened with that feedback? Have we actioned it? Is it just in the backlog? Yeah, and we can see, each of these queries will have a name. This will be the name of the function. In this case, we're expecting it to be a slice or many records returned. And I've roughly tried to break it up in terms of, the different tables we have. So there's nothing like super crazy here. We're using the $1, $2 to represent input, which I don't think is anything revolutionary, anything that should be super confusing. So yeah, so this is just the various tables and some of the queries I need to do. So every time I need to do a new query, I just come over here and add it. So this is just going to be any interaction with the database, of course, that the app needs to do. And so I know exactly what's happening, and I'm writing it, and there's no magic going on behind the scenes. It's just SQL. We're just running SQL that I've written. So that's kind of the beauty of sqlc. It's just very simple, and I think it fits really well with the kind of web app I'm trying to build with HTMX, Postgres, Go. Just keep it really simple, just really basic. Then if we take a look at migrations, even though this app isn't properly live and isn't collecting data, or I don't really care about the data, I am running migrations because when it gets deployed, there is quote unquote production database, and I can't be bothered to keep clearing it and keep recreating. So I'm just creating new migrations as we go along. And so you can see there's a few. If we take a look at this, I was trying to add, there might be a better way to do it, but, adding row level security to try and simplify the queries a little bit. And you can see we've got the up part, and then we'll have the down part to delete those policies when they're done, etc., etc. And then if we go to query.sql.go, so this is to generate code. This is basically everything sqlc is generating. And this is that models file I was telling you about. And so loads of these will be tables, and then there'll be some other types that we need just because of what we're returning back. It will create some of those types as well for us. But yeah, again, I'm not touching any of these. Query.go, which is that, that interface I was talking about, which I then use to generate some mocks from using mockery. Database.go again. So this has all been generated by sqlc. And then there's some custom bits I've written. So to run my migrations on startup, and then also allowing us to run them for tests and other stuff that we might need using PGX in this case. And I think this is some PGX code I've written myself to get a new pool and kind of link PGX with sqlc. And there's a few other things I'm doing here around to enable us to do row level security. There might be a better way to do this, but I'm just saying the organization slug, so we can then limit what users see by default. And I've got a retrying database, so depending on certain errors, we retry. So if there's like a connection failure or connection timeout, we retry on certain errors. I've just written some functions that basically let you do that. This project is not publicly available, but lots of this code is available in Banterbus, so you can go take a look there. But yeah, that's basically it. I'll probably do another video going more in depth how I've actually integrated PGX with sqlc. This was just like a start video of how you can use sqlc and why you might want to, just to get you started. Yeah. Thank you for watching that video. Hopefully you found that useful. Let me know any other topics you want me to cover, and give me any feedback on the video as well. That'd be greatly appreciated. Did you know I use Nix, by the way?